Hi everyone, so it's Coach Fred here, and today we're going to be talking about how we can prove that lines are actually parallel to be able to do things with them. So in the last unit, we were using the corresponding angle postulate and alternate interior angles, and we basically said that if we had two lines and they were parallel, like this, and we cut them by a transversal, then there were different relationships between the alternate interior angles and the corresponding angles. But what if we're not told the lines are parallel? And so this is where we have to think backwards. We can't just assume, remember, that things that appear parallel are. So here, let's look at this question. It says, are lines HI and TN parallel? Well, in order for these lines right here, this one right here, HI and TN, in order for them to be parallel, we'd need to be able to find a parallel relationship. All right, so if those are the lines that we're trying to see if they're parallel, then this would be the transversal, because that's the line that cuts through them both. All right, so I looked at them and I'm like, well, if that's the case, well, these are corresponding angles. So let's see if those corresponding angles are actually congruent. All right, so 61 and 23 gives me 84. And 62 and 22 gives me 84. So corresponding angles are congruent. So yes, HI and TN are parallel because corresponding angles are congruent. All right, let's talk about WI. So let me erase that. WI and AN. All right, now again, we can't assume that they are parallel just because they look it. Okay, so I'm trying to see if this line right here and this line are parallel. Okay, so if that's the case, then this is the transversal. And the corresponding angles then would be 62 and 61, which are not congruent, so we don't have enough to say that WI and AN are parallel. No, because corresponding angles are not congruent. Oops, like that. So hopefully you see that this is not a really hard concept, but you do have to be able to prove one of those relationships in order for the lines to be parallel. All right, so go ahead and label, in this example, this M and this N. And it says, find the value of X that makes the lines parallel. All right, I know they appear to be parallel, but in order for them to be parallel, these angles, which are corresponding, we would need them to be congruent. So to find the value of X that would make them congruent, you just set them equal to each other. Because by setting them equal, remember, equals means is the same as. So when you solve, the value of X is going to make them equal to 65. All right, so we're going to do the algebra. We're going to subtract 5, and we get 3x equals 60, and x equals 20. So if we plug in 20, we get 3 times 20, which is 60, plus 5. So they are congruent, so we can now say the lines are parallel. Okay, hopefully that's making sense to you. What we're actually doing is we're doing the converse of the corresponding angle postulate. So just watch for a second. The corresponding angle postulate, I call it CAP, says that if two parallel lines are cut by a transversal, you don't have to write this down, by a transversal, then corresponding angles are congruent. Okay, I'd like you to try and write the converse to that. I'd like you to press pause and write the converse. All right, so if you did that, if you pressed pause and wrote the converse, then you would have flipped it. So if two lines are cut by a transversal, so kind of need to keep that part in it, and corresponding angles are congruent, then the lines are parallel. All right, so in class tomorrow, we're going to be working with trying to find values that will make the lines parallel. Here, let's try another example. So I want you to label this line A and this line B, and it says, is there enough information in the diagram to conclude that angle A is parallel to angle B? Explain your answer. All right, so I'm looking at this and I'm like, okay, well, I know that this is 70 degrees. And then because I know the linear pair postulate, this angle forms a linear pair, so I know that this is 110 degrees. Okay, sorry, not 100, 110 degrees. Okay, and then I know if this is 110 degrees, well then this is 70 degrees because they're linear pair. So now by doing that, I have lots of different things happening here. I see that the alternate interior angles are congruent. I see that the same side interior angles are supplementary, and I see that the corresponding angles are congruent. So yes, there is enough information to prove them parallel. And you could use any one of the reasons. You could do same side interior angles are supplementary. You could say that corresponding angles are congruent, or you could say alternate interior angles are congruent. But by doing just a little bit of work, you can actually say, yes, they are parallel. So now they're parallel. Sometimes I might be giving you questions where you're going to try and find the values of x that makes them parallel. So first of all, this diagram is missing a right angle, so go ahead and put that in. And it wants us to prove or find the values that make these two lines parallel. So in order to do that, I'd really need either corresponding angles to be congruent, or, I know this is a linear pair, I would need same side interior angles to be supplementary, but since this is 90, I know I would need this to be 90. Well, in order for that to be 90, then x plus 40 equals 90, so we know that x would be 50. So in order for the lines to be parallel, I need that to be a right angle. Therefore, these lines would be parallel, and that's the value of x that makes them parallel. Now, if I made x 40, they wouldn't be parallel. Okay? All right, a little bit harder, more going on. I want to find the values x and y that make AC and DF parallel and AE and BF parallel. Well, I'm going to start with AC and DF. So here's AC. I'm not going to highlight the whole. Here's AC and DF. All right, so if those are the lines I'm trying to prove parallel, then this is their transversal. All right, so I would need alternate interior angles, because these are alternate interior angles, to be congruent. So to find the value of x that's going to make them congruent, I set them equal to each other. All right, so I'm going to add 20, subtract x, so I get 70 equals 2x, and so x equals 35. So if x is 35, then alternate interior angles are congruent, and therefore the lines are parallel. It's not really all that challenging, but now I want to look at the other side. I want to prove AE and BF. Now, here's AE, and now here's BF. So this would be the transversal I'd be working with, because that's the side of both those angles. Well, if x is 35, then I know this angle is 85 degrees. So I would need 2y minus 5 and 85 to be supplementary because they're same side interior angles. So if this is 85, then 180 minus 85 gives me 95. So I need this angle to be 95 degrees. So to find the value of y, I would do 2y minus 5 equals 95. So I'm going to add 5 to both sides, and I get 2y equals 100, so y equals 50. Therefore, if y is 50, then AE is parallel to BF. All right, guys, I'm going to stop there. So it's just a little process of using the converse. I want you to try the problem that I'm putting on the board now, and have a great day.